The evolution of the Geron family of unmanned aerial vehicles, stemming from what was initially perceived as a relatively unsophisticated, mass-produced loitering munition, represents a significant case study in rapid military adaptation and technological escalation, transforming a seemingly ordinary weapon into a formidable, intelligent system capable of high-volume deployment.
While the foundational design was inherently simple, optimized primarily for hitting stationary targets through basic satellite navigation signals, the subsequent modifications suggest a comprehensive effort to enhance destructive power, improve survivability against increasingly active electronic warfare environments, and establish operational flexibility.
One clear line of development involves the sheer increase in payload capability. The initial Geron 2 variants reportedly carried high explosive warheads around 50 kilograms, a considerable weight when contrasted with standard 152mm artillery shells, but subsequent requirements appear to have necessitated the integration of significantly heavier payloads, perhaps in the range of 90 to 100 kilograms.
It is highly likely that this increase in kinetic effect, while providing a greater strike capability necessary for robust infrastructure or protected military assets, inherently imposes a trade-off, potentially reducing the overall operational range of the platform. However, the diversification of warhead types is perhaps more revealing than the simple increase in mass.
Intelligence suggests the deployment of specialized payloads, including cluster munitions for area denial and targeted anti-personnel effects, and notably thermobaric warheads, which offer a substantially greater localized blast and incendiary effect compared to conventional explosives.
This deliberate variety allows for complex, coordinated strike packages, where, hypothetically, a flight of drones could sequence attacks, an HE variant to breach initial defenses, followed by a thermobaric variant to maximize damage and cause secondary fires, and potentially concluded by a cluster munition variant designed to sow confusion and delay recovery efforts by saturating the area with submunitions, perhaps even with delayed fusing mechanisms.
The most critical area of transformation, however, lies in the progressive smartening of the guidance systems, a direct response to aggressive countermeasures deployed by opposing forces. Early models relied predominantly on signals from the indigenous GLONASS satellite navigation system, supplemented perhaps only by basic inertial guidance.
However, facing escalating EW jamming and signal spoofing attempts, engineers appear to have integrated advanced navigational modules, such as the Cometa series, to improve resistance. Beyond mere navigational hardening, the introduction of rudimentary two-way communication capabilities, primarily through the integration of cellular modems and small video cameras, marks a pivotal shift. While these cameras are unlikely to offer the real-time, high-fidelity control afforded by dedicated first-person view drones, they theoretically provide crucial reconnaissance data throughout the flight path, and critically, offer a mechanism for post-strike confirmation or potentially mid-course adjustment of the target coordinates based on updated information.
The hypothesis that these platforms could receive updated targeting packages mid-flight or adjust their trajectory based on localized intelligence gathered by the onboard systems represents a substantial leap from a simple flying cruise missile to an adaptable operational asset. Furthermore, in specific operational theaters, particularly near the front line, some variants are believed to be adapted for direct radio control, functioning akin to long-range FPV systems, though this capability is likely restricted by radio line-of-sight limitations. The reported placement of communication antennas on the wingtips underscores an emphasis on maintaining signal integrity, even against mobile targets. Looking further ahead, certain unconfirmed reports suggest experimentation with extremely sophisticated long-range guidance solutions, including the controversial integration of commercial satellite terminal equipment, such as Starlink. If substantiated, this would offer the capability to control these systems across vast distances, effectively transforming them into strategic FPV assets across the entire theater, enabling highly precise, almost surgical attacks that would pose a unique threat to high-value assets, such as aiming directly at an opening hangar door. Simultaneously, significant engineering effort has been directed toward enhancing the platform's survivability against the highly mobile air defense teams deployed by adversaries. To counter ground-based fire, the gyrans are frequently observed flying at maximum feasible altitudes, often between 3 and 4 kilometers.
Furthermore, the initially standard white fuselage has reportedly been replaced with specialized light-absorbing paint treatments designed to reduce visual signature significantly, making nocturnal interception markedly more challenging. Against dedicated drone interceptors, particularly FPV drones, some long-range variants are believed to have been equipped with automated evasion systems capable of detecting the telemetry signals of incoming interceptors and executing sudden, sharp changes in altitude and direction.
Because the operational time and flight ceiling of typical interceptor FPVs are highly limited, such instantaneous avoidance maneuvers severely restrict the engagement opportunities for the opposing operator. Further complicating interception, reports indicate the use of low-power commercial laser transmitters mounted on the girons, which, while not intended as direct weapons, are highly effective at blinding or confusing the optical sensors of incoming FPV drones.
Finally, perhaps the most innovative countermeasure against radar-guided surface-to-air missiles involves the deployment of towed decoys, simple corner reflectors encased in lightweight casings designed to dramatically increase the radar cross-section being presented to the defender, diverting expensive radar-guided missiles away from the actual target platform. This measure, while increasing the complexity of launch preparations, is considered a cost-effective method to stress and deplete the enemy's high-cost SAM inventories.
All these enhancements, from heavier warheads to specialized protection systems and upgraded navigation modules, inevitably impose a collective penalty, primarily in terms of performance metrics like range or maximum payload. However, given that the operational requirements frequently fall well within the theoretical maximum range of the platform, perhaps only requiring 500 to 700 kilometers of travel versus a potential 1,500 kilometers, the operational utility of increased survivability and destructive power likely justifies the reduced range capacity. Thus, the current operational picture is one of a highly diversified fleet, a swarm, where different Gerin variants, distinguished by guidance packages, warhead types, countermeasures, and even physical appearance, are orchestrated to achieve a combined synergistic effect on targeted infrastructure, marking the definitive transformation from a simple, basic weapon system to a complex, adaptable, and increasingly intelligent instrument of strategic strike.
She underscored that proceeding without Belgium would be exceedingly difficult, given that the vast majority of the wealth is physically held within its jurisdiction, confirming that Brussels' cautious position continues to dictate the pace of Europe's most urgent financial decision regarding the war.
However, strategic demands seemingly necessitated further lethality, driving an immediate modernization trajectory that saw the deployment of heavier HE payloads, reportedly in the range of 90 to 100 kilograms. While this increase in destructive force might potentially involve a trade-off in the UAV's overall operational range, a key challenge in aeronautical design, where payload and fuel capacity must be meticulously balanced, the evidence suggests that Russian industry is simultaneously manufacturing various Gerin variants bearing these different HE payload sizes to maintain mission flexibility. Moving beyond merely increasing the destructive weight, the diversification of the warhead types represents a far more significant shift. Data indicates the development and integration of cluster munitions for the Gerin series, designed primarily for anti-personnel use and area denial, as well as the adoption of thermobaric warheads.
Thermobaric explosives, which utilize ambient oxygen to create a high-temperature, sustained blast wave, offer substantially greater destructive potential against entrenched positions or structures compared to conventional HE, often resulting in secondary fire effects. The operational advantage of this multi-payload strategy is considerable, allowing for synergistic attacks against complex targets.
For instance, it is highly likely that an initial wave of Gerin 2s carrying heavy HE warheads could be tasked with structural demolition, followed by thermogaric variants designed to maximize fire and secondary damage, and finally, cluster munition variants aimed at impacting surrounding equipment and personnel, perhaps even deploying delayed action submunitions to complicate and delay recovery efforts, thereby amplifying the overall operational impact of a single drone strike package.
This physical enhancement of destructive power is complemented and indeed enabled by the parallel smartening of the guidance and control systems, addressing early vulnerabilities in the basic Gerund design. The early variants relied primarily on GLONASS satellite navigation signals to hit fixed targets, potentially supplemented by inertial navigation or terminal optical image recognition.
When Ukrainian forces rapidly deployed sophisticated electronic warfare systems to disrupt satellite signals, the effectiveness of the initial Geran deployment faced immediate challenges. In response, one key hypothesis is that Russia has continually improved its positioning systems, potentially integrating sophisticated anti-jamming modules like the Cometa series, a process that analysis suggests is ongoing and iterative.
The next critical step in this intelligence evolution involves the installation of feedback mechanisms, specifically cellular modems containing mobile SIM cards and miniature video cameras. Although these cameras do not appear to allow for true real-time high-fidelity FPV control akin to specialized tactical drones, they provide crucial operational data. These additions allow for mid-flight reconnaissance data collection and, perhaps most critically, the confirmation of target acquisition or impact assessment. Theoretically, these feedback systems could allow mission controllers to receive information regarding the flight path, environmental conditions, or even facilitate last-minute retasking to alternative targets during the lengthy cruise phase.
While some dedicated radio-controlled FPV variants of the Gerund system are reportedly being used closer to the line of contact within standard radio control ranges, the long-range variants benefit greatly from these persistent data links. Reports from Ukrainian sources further suggest advanced communications antennas placed on wingtips, potentially enhancing effectiveness against mobile targets.
Looking ahead, future variants could possibly incorporate fiber optic guidance cables, enabling the Geran to attack targets like a short-range air-to-ground cruise missile, rendering it immune to localized electronic jamming, though the engineering challenges and logistics involved in deploying such a system at scale remain substantial.
The most potent and perhaps most alarming development, if confirmed by verifiable evidence, pertains to the potential integration of Starlink satellite terminals onto certain Geran variants. This would represent a qualitative leap in capability. A Starlink-equipped Geran could theoretically be controlled via satellite link across the entire depth of Ukrainian territory, effectively transforming it into a long-range FPV-style weapon.
This capability would allow for unprecedented precision, enabling operators to target highly specific and potentially mobile objectives, such as accurately steering the UAV into an open hangar door containing high-value assets like F-16 fighter jets. This level of precise targeting, combined with the earlier discussed payload diversification, forces a fundamental reassessment of defensive strategies, compelling Ukraine to expend increasingly scarce and expensive air defense resources against a mass-produced, relatively low-cost threat. The ongoing transformation from a simple sacrificial drone to a versatile, intelligent platform capable of mass production and tactical adaptation underscores a significant shift in modern military doctrine. The blend of low-cost, high-quantity production, increased lethality, and continuous technological enhancement suggests that the Geran system is now less a single weapon and more a customizable instrument of strategic pressure, designed to deplete enemy resources and overwhelm existing air defenses through sheer complexity and volume.
The analysis and commentary presented in this video are based on publicly available sources and open-source intelligence and represent the channel's interpretation of this complex and evolving conflict landscape. It must be acknowledged that the deployment and effectiveness of such advanced modifications, particularly those involving sensitive technologies like Starlink or specialized anti-UAV countermeasures, remain subject to the fog of war and are difficult to verify independently, meaning that the true operational success and scale of these adaptations should be viewed cautiously.
Nevertheless, the trajectory of adaptation strongly indicates a sustained effort to maximize the Gerund survivability and lethality, ensuring that these drone swarms, comprising myriad types, countermeasures, and even physical appearance,
are orchestrated to achieve a combined, synergistic effect on targeted infrastructure, marking the definitive transformation from a simple, basic weapon system to a complex, adaptable, and increasingly intelligent instrument of strategic strike.